Okay, so welcome to the next video in our series, and we're going to be looking at today the features of a circle. And circles are really exciting, really special shapes. It might sound silly to say that, but essentially that's what the Go is. So, they're round, no sides, no internal angles, just kind of loops around back on itself. You've seen circles before probably. And a lot of this could be revision, but just going to cover it. It's just going to be here so you'll always have access. So, first one that we need to talk about is the radius. So, if we have a center of a circle here, and this from the center we extend straight out like this, that's our radius, okay? So from the center to the edge of the circle is the radius. And the other one length we have to worry about with our circles is something called the diameter. And so this goes across the circle from edge to edge, going through the center. Okay, so not either side, straight through the center is our diameter. Okay, and these two here, both radius and diameter, are the number 1 and 2s that you really need to worry about. Okay, everything else is kind of added extras, I suppose. Alright, so we have as well a chord, and what this is a line that goes from edge to edge but doesn't go through the center. Okay, so the diameter is the one that goes through the center, whereas chord is one that just goes from edge to edge without necessarily going through the center. Well, it doesn't go through the center. And an arc is a line like this, a length that's the same as a circle. Okay, so you kind of want to ignore all this green part here and just look at the red part here. That's called an arc. Okay, now usually when you're dealing with arcs, you're told some angle theta here in degrees that this arc extends. Okay, so this is some angle theta this arc is going to be a part of. Okay, so arcs you'll see a bit, chords not so much. Right, sector is the next one. Sector is if we fill in all of the stuff that was in our chord before. Okay, so as you'll see, the sector here is the same as this chord, just being colored in. So sector is the area, chord is the line. Now, same as segment. Segment is to the arc what sector was to chord. So segment is a colored in arc section. Okay, so that's area stuff that'll be coming soon with our circle things, but again, it's something I think you're going to see more than the sector, is this idea of segment, piece of a pie, so to speak. Right, so they're just our basic little pieces of circles, just to see them again. So we got the radius and diameter. These are our number 1 and 2s that you really need to get a hold of. And in fact, radius really is the one that you'll use more often than diameter, but you need to understand both of them. So we had chord and arc. Again, not as important, but arc you really need to get familiar with. Chord, don't worry too much about. Sector is here, and it's probably not one that you'll have to worry about too much, but there it is. And it's an area one. Segment, area again, and I think you'll see a bit more of it rather than the sector. In fact, with the segment, I forgot to mention, it has an angle associated with it as well. Theta, I'll call it theta just for the sake of it. So segments also have an angle associated with it, and you'll be told that when you have to work out a segment. Okay, what we need to talk about today is circumference. So we've done perimeters before, so perimeters of squares, or rectangles, and triangles, and composite shapes of those, but we're also going to be talking about perimeters of circles. Now, circles are so special that they get their own name. Perimeter is for regular polygons, but circumference is a special word that's reserved for circles. It is like the perimeter of the circle. Okay, so all this part around the edge, forget about the middle. Circumference is just if you're walking around the circle, how far is it? Okay, to go from this point here, travel around and around until you come back to here. That's the circumference of a circle. Okay, now the number pi. This is one that I'm sure will have plenty of contention within class. Okay, it is a number, and this is the Greek letter that has been reserved for the number pi. It is the Greek letter for the letter P, and it's a really special one. It's been reserved. You won't see this occurring in any other way other than referring to pi. It's not used as x's and y's. It's not used like thetas, alpha, beta, gamma and stuff are for angles and such. Pi is pi. It means that particular number, okay? Think of it like a 7 or an 8. That means that kind of amount, that concept of 7 or 8. Pi is pi, okay? Now, a little bit about it. The number pi, written like this with giant capital letters, is an irrational number. Now, I don't know if you guys have had much experience with irrational numbers. Irrational numbers is, I think I talk about that a little bit lower. So irrational numbers, number pi is an irrational number that is the ratio of any circle to its diameter. Okay, so if we just scroll down here, pi is equal to the circumference of a circle divided by its diameter. Any circle. Doesn't matter if it's this big or this big or this big or, you know, this big. It will be the circumference divided by the diameter. So the circumference divided by the diameter, which was the length that goes, that goes across it, that is pi. Okay, the circumference divided by the diameter always comes out with pi for any circle. Okay? So let's talk about this irrational number thing. An irrational number is a number that cannot be expressed as a ratio a over b of two integers. So for instance, 0.333 recurring can be represented as 1 over 3. Or so 0.25 could be represented as 1 divided by 4. These things are what's called rational numbers. Rational numbers, okay? Whereas pi is irrational, okay? It cannot be expressed as a number over a number, okay? So pi is often used in its shortened form or what you'd call approximate form. So 3.1415926 keeps on going and going and going forever. And ever and ever and ever. That's it. It's called a transcendental number for other reasons to do with that as well. So you really need to think of pi being this kind of magical number that just happens to represent the ratio of all circumferences to the diameter of that circle, okay? And in class, we will be using the calculator button pi, okay? So get to know it. Get to know your pi button, because I don't want to hear any pi equals 3.14s or 3.14159s, or I don't even want to hear breathed in ours that it's 22 over 7. No. Okay, pi is pi. All right, we'll use approximations of it using your calculator, but pi is pi. Right. So since the diameter that went all the way across was the radius being halfway, which was from the center to the edge, gives us this relationship that the diameter of a circle is equal to twice the radius, okay? And we figure out the circumference using, if we scroll up quickly back up the top, we see that pi is the circumference over the diameter. That means that we can work out the circumference of a circle by pi times the diameter. So that means that circumference is also equal to pi times twice the radius. And circumference equals 2 pi r is probably the way you'll mostly use the circumference formula. So if we work this out, we're going to have that the circumference is equal to 2 times pi times 3, which is equal to 18.8. Well, that's a 3. 18.85. Okay, now it's rounded off, but 18.85 centimeters around this circle here. Okay, now finding the length of an arc, that's something else that we might have to do. So the first thing we need to do is find the ratio of the arc to the circumference. Okay, so we kind of want to think, how much of the circumference is this arc? Okay, so we look at that as a fraction, so it's the angle of the arc, so over 360. I've just told you that this angle theta is 60 degrees. So that means that 60 over 360, so that means that this arc goes 1/6 around the circle here. Okay, then once we've done that, we do our length of the arc. So if the circumference equals 2 pi r, then we'll have the arc being 1/6 times 2 pi r, which is equal to 1/6 times, that's a bit big, times 2 times pi times 3 centimeters, which is our radius. And so it's going to be 1/6 of, what did we have before? 18.85, which is equal to well done. It's equal to 3.1415, blah, 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 which you would have recognized as pi. That's kind of totally a mistake. Well, not a mistake, just accident. Pi centimeters, that arc is, but we'll see that working out in a little more, less coincidental ways later. Okay, so that's essentially our introduction to what circles are. We'll be moving on into area soon, so please just have a quick little practice of that and be ready to move on into areas of circles and how to use them, and look forward to seeing you in class. Thank you.